Hey there folks, Mr. D here, and in this video we are going to be introducing the elusive unit circle. I know you've been looking forward to it throughout these videos. Today is finally the day. Just as a heads up, there will be multiple points where you're probably going to want to pause the video to get things jotted down, or maybe even take a picture or screenshot. All of the notes will be provided online, so you guys will have access to those as well. All right, so first, let's kind of recap. We have two special right triangles that we kind of discussed earlier in this unit, and you've seen these a handful of times back in geometry. Those two triangles are 45, 45, 90 and 30, 60, 90 triangles. Now these special patterns are going to show up and manifest within the unit circle a handful of times, and the way that they're going to do that is when we set the hypotenuse equal to 1. So by setting the hypotenuse equal to 1 for each of these, what we can do is find the leg lengths here. And what I mean by that is for 45, 45, 90, I know the hypotenuse is that side length times rad 2. So if I'm saying side length times rad 2 is equal to 1, then each side length is 1 over rad 2. We don't like having that radical in the bottom though, so we'd rationalize that denominator by multiplying top and bottom by that square root of 2. And when we do that, we'd get square root of 2 over square root of 2. Now we'll do the same thing over here on a 30, 60, 90, where we have a hypotenuse of 1. Well, the hypotenuse is 2 times the shorter side length. So the shorter side length here would have to be 1/2, which means the longer leg would be 1/2 times rad 3. Well, that'd be rad 3 halves. Now the reason why we want to have these measures kind of ingrained in our brain is that these are going to be showing up a whole bunch of times on the unit circle. So if you want a more precise looking or something with cleaner handwriting, here's a diagram for you. If you want to pause the video here to jot these down, take a picture, whatever. All right. So let's move on. Oh, actually, before we do that, another reason why we want to do this is for trig functions. I'm going to pick on 30, for example. If I wanted to know the cosine of 30 degrees, what I could do is I could use this reference angle as an example and say cosine is, well, the adjacent side, rad 3 over 2, over a hypotenuse of 1. So the cosine of 30 is rad 3 over 2 over 1. Well, anything divided by 1 is just itself. So the cosine of 30 degrees would be rad 3 over 2. So the reason why we like to have a hypotenuse of 1 is it makes finding the cosine and sine much easier because that denominator there is just 1. All right, onward. The unit circle. Unit, by definition, means something with 1 involved. So unit circle has a radius of 1, and it's centered at the origin. So it's centered at 0, 0, right here. And it goes up 1, down 1, left 1, right 1 in each direction. So at 0 degrees, we'd be at 1, 0. At 90 degrees, we're at 0, 1. At 180 degrees, we're at negative 1, 0. At 270 degrees, we're at 0, negative 1. And then we're back to 360 over here. Just as a reminder, when we talk about angle measures and standard position, we always go through the quadrants 1, 2, 3, 4, counterclockwise. Now within the unit circle, what we can then do is draw in a triangle using the radius of the circle and then dropping to the x-axis. So what I could do is I could put an angle in that unit circle, and then I could drop down to the x-axis. Always the x-axis, never the y, and I can create a right triangle. Now assuming theta is the angle in standard position. So assuming theta is this little angle here between the radius and the x-axis, then the cosine value is going to be the x-coordinate. So however far out we go, this is the x-coordinate here, that's going to represent our cosine value of that unknown angle theta. The y value is going to represent the sine value of that unknown angle theta. So here we have kind of like the starting point of what the unit circle is going to look like. We have a whole bunch of different angles that could possibly show up. Each one of these angles is going to get coordinates off to the side. We're going to start noticing patterns within these coordinates, but it's just kind of important to kind of see where they come from. Each one of these represents an angle that could be drawn. So for instance, I can make a little right triangle right there. I can make a right triangle for this purple segment. I can do the same thing for that green triangle in that first quadrant. So all of these triangles will have a right angle involved, and they'll all be certain patterns that we're familiar with, the 30, 60, 90, or 45, 45, 90. So let's start unpacking. First, let's talk about a 30-degree angle. That's going to be the first quadrant here. So a 30-degree angle is going to be 30 degrees off the x-axis. Using our special triangle pattern, assuming the hypotenuse was a 1, I can think of this as a triangle in which the x value was rad 3 over 2, so I went out rad 3 over 2 and up 1/2. So the x and y coordinates for a 30-degree angle on the unit circle would be rad 3 over 2, comma 1/2. And remember, that represents our cosine value and then our sine value. If we do that same thing with our 45-degree angle, here's our special pattern in which the hypotenuse is 1. If I were to sketch that triangle in here, always go down to the x-axis, never the y. My x value would be rad 2 over 2. My y value is also rad 2 over 2. Essentially, all I'm doing is plagiarizing these values here. That's where I'm getting these guys. And what we've just found is the sine and cosine values of a 45-degree angle. Let's do a 60-degree. So 60 is going to look the exact same as 30. It's just the 1/2 and the rad 3/2 have flip-flopped. And that kind of makes sense because all we did is just change the reference angle. So a 30 and a 60 are going to be eerily similar. We just kind of flip-flopped who goes where. So we go out 1/2 and we go up rad 3 over 2. That's going to represent the cosine of theta, so cosine of 60, and then the sine of theta, sine of 60. If you're ever confused on which one comes first or second when you're talking about the whole cosine sine, if you remember, it goes alphabetically. So cosine first, then sine, C, then S. All right, let's start putting that all together. Within the first quadrant of that unit circle, here are the angle measures and their corresponding cosine, comma, sine values. So it's cosine, comma, sine for all of those. We have a 30-degree angle. We have a 45-degree angle. And we have a 60-degree angle. So just by looking at this, if I wanted to say, hey, what is the sine of 30 degrees? Well, I'd go to 30 degrees, and sine is the second number here, so that would be 1/2. So sine of 30 degrees would be 1/2. So when we start filling in the unit circle, what's going to happen is it's kind of like a quick reference for trig values at certain angles. All right, now let's expound a bit. We've already talked about the first quadrant. So we've already kind of focused on just this first quadrant and what angle measures come out of that. So that's what we have over here, just the first quadrant. But what we're going to start seeing, and you can already kind of predict this with the color coding, is that there's going to be repeated behavior within each one of these angle measures. So we're going to go through and kind of plug in all of these values. The first thing I'm going to do is the black angles. So I've got 0, 90, 180, and 270. I guess you could also argue that this is 360. These are called quadrantal angles. They're called quadrantal angles because they're angles that separate two separate quadrants. It's like 90 degrees is not in quadrant 1, nor is it in quadrant 2. It is the borderline. It is the separation between quadrant 1 and 2. So we have 0, 90, 270, and 360 are off the board. Now I'm going to go through my red angles. All of these red angles are going to be 30 degrees away from the x-axis. So that first one is a 30-degree angle. Over here, if this is 30 degrees away from 180, I know it's between 90 and 180, but it's 30 degrees shy of 180. That has to be 150 because I did 180 minus 30. So we have a 150-degree angle there. If I go past this red angle here, this is 30 degrees past 180. So 180 plus 30, that's going to be 210 degrees. Quadrant 4, if I go past 270 but not quite to 360, I want to know what is 30 degrees just shy of a full rotation. So 360 minus 30 gives me 330 degrees. So there's all those red angles filled in. Now let's go into the purples. All of the purple degrees, the purple angles, these will all be 45 degrees away from the x-axis. Always from the x-axis, never from the y. That first one is just a straight up 45, and we already knew that from the previous discussion there. Over here in quadrant 3, this would be 45 degrees before 180. So 180 minus 45, that's going to give me 135 degrees. So 135 degrees. Down here in quadrant 3, this is 45 degrees past 180. So 180 plus, since I'm going past it, 45, gives me 225 degrees. This purple angle over here in quadrant 4, it's past 270 but not quite to 360. In fact, I've just shy of 360 by 45 degrees. So if I did 360 minus 45, I would get 315 degrees. Now we have all of our purple angles all set. Now let's talk about the green ones. The green angles are all 60 degrees away from my x-axis. So first quadrant would just be a straight up 60. Quadrant 2, this is 60 degrees away from the x-axis. So if this is 180, if I go 60 degrees before that, I'd be at 120 degrees. If I go down to quadrant 3, if I go 60 degrees past 180, 60 degrees past it, I get 240. And if I take a look at quadrant 4, if I go 60 degrees before 360, again, we always go to the x-axis, never to the y, always to the x. 60 degrees just shy of 360, that would be 300 degrees. Oop, I forgot to cross off the 180 over here. So right here, we have the unit circle filled in with just the angle measures. Once you have the angle measures, you can go through and assign what we already know to be the cosine and sine values from that first quadrant. You can assign those to each angle measure. And what we're going to see is these values just kind of repeat over and over and over. All of the red angles will be rad 3 over 2, comma 1/2. All of the purples will be rad 2 over 2, comma rad 2 over 2. All of the greens will be 1/2, comma rad 3/2. The only thing that's going to change is positives versus negatives. That's it. Now, just as a refresher, on a graph, if this is the origin, as you go to the right, your x values are positive. As you go to the left, your x values are negative. Vertically speaking, as you go up, your y values are positive. As you go down, y values are negative. So what's happening is in each quadrant, we're kind of going through and saying, okay, which value x or y is positive, which value x or y is negative. And remember, as we look at these, the x values represent the cosine. The y values represent the sine. So let's take a look-see. If I start off with the 30 degrees, we're blue now. So 30-degree angles. anything with a 30-degree reference angle has rad 3 over 2, comma 1 over 2. All that changes is the positive or negative behavior of the x and y values. So quadrant 1, positive x, positive y. Quadrant 2, negative x, positive y. Quadrant 3, both negative. Quadrant 4, positive x, negative y. So all of these angles that I have highlighted in blue, they are all 30 degrees away from the x-axis. They all have the same sine and cosine values. The only thing that changes is positive or negative behavior. Same is true now for the reds. So all of the 45-degree reference angles, so 45 degrees away from the x-axis, whether it's above it or below it, they're all going to have rad 2 over rad 2 for both the x and y. We just need to figure out who's positive, who's negative. Same can be said for the 60-degree reference angles. Everything here in green is 60 degrees away from the x-axis. They're all going to have the same x and y values, and that is 1/2 comma rad 3 over 2. Only thing that changes is how many negatives show up. All right. If you want little ways to remember this, as you count up from the x-axis, your y values start off 0, 1, 2, 3, and then to a full 1, and I'll explain kind of how that looks over there. Your x values kind of count down from the y, 0, 1, 2, 3. If you want, you can think of each one of those as a radical. So rad 1 is just 1, rad 2 is rad 2, rad 3 is rad 3, and over here, rad 4 would be 2. 2 over 2 is 1. So if you want little easy ways to remember it, the y values count up, 0, 1, 2, 3, 4. X values count down, coming this way. Now there are ways to remember this. We'll talk about those in class, but for the most part, you'll be given this unit circle in class, and we're just going to be kind of expecting that you know how to use it, and we're going to be going through that more in depth in future lessons. This is just kind of the origin story of the unit circle. In pre-calc next year, though, you will have to be able to generate this thing from scratch. All right, so let's get going on using the unit circle to our advantage. What I'm going to do, just so I'm not constantly scrolling back and forth, is I'm actually going to bring this unit circle with me so that way I can have it for reference. Okay, first one, we want to know what is the sine and cosine of 30 degrees. Well, 30 degrees is this guy right here. Cosine, comma, sine every time. So cosine is the x value, sine is the y value. So rad 3 over 2, comma 1/2. Cosine of 30 degrees is rad 3 over 2. Sine of 30 is 1/2. Let's do number 2, 45 degrees, right here. They're both going to be rad 2 over 2. Let's see what number 3 has. Let's see, 120 degrees. So I'm going to look at my unit circle. 120 degrees right here. My cosine is negative 1/2. My sine is rad 3 over 2. So cosine, comma, sine. For 120 degrees, I've got negative 1/2 for my cosine, and then rad 3 over 2 for my sine. Let's see, number 4, 390 degrees. I typically like this to be between 0 and 360. So I'm going to find a coterminal by subtracting 360 away from that. And I'm going to consider that to be a 30-degree angle. Well, if it's a 30-degree angle, it's going to have the exact same answers as what we just saw up here. So I'm going to plagiarize myself. There we go. A 390-degree angle is the same as a 30-degree angle. Let's see, negative 225. Oof. Yet again, we've got a negative angle. So let's find a coterminal because I don't want any negative nonsense. Well, to do that, I'm going to add 360. Remember to find coterminals. You can either add or subtract 360 at your will. When you do that, you'll get 135 degrees. So now looking at my unit circle, I'll find 135 degrees right here. My cosine is negative rad 2 over 2. My sine is rad 2 over 2. So negative rad 2 over 2 and rad 2 over 2. Let's see, negative 30. Well, don't like negative angles. Let's add 360 to it. That's going to be 330 degrees. 330 degrees is this guy right here. Looks like I've got a cosine of rad 3 over 2 and a sine of negative 1/2. In the home stretch. Let's see, 180. Ooh, we've got a quadrantal angle. So 180. Right here, this would be cosine is negative 1, sine is 0. Cosine negative 1, sine is 0. 270, another quadrantal angle. Cosine is the x, sine is the y. Cosine is 0, sine is negative 1. Then we've got negative 150. Oof, not thrilled about negative angles. So let's add 360 to that. So negative 150 is really the same as 210 degrees. So 210 is right here. If you like negative angles, you could always go backwards. Negative 30, negative 45, negative 60, negative 90, negative 120, negative 135, negative 150. But I find it easier to just deal with positive angles between 0 and 360. All right, cosine is negative rad 3 over 2. Sine is negative 1 over 2. All right. So I'm going to suggest if you did not get that written down, go ahead and take a picture of the screen here. If you need this unit circle for reference, it will be showing up in a myriad of places, but feel free to pause the video, take a picture, do what you got to do if you need that for your notes. And that's going to go ahead and conclude this video, but you know the drill, folks. If at any point you are stuck, confused, whatever, have any questions, please do not hesitate to ask. And as always, good luck, have fun, be safe, roll tide.